how the topic application of calculus is test in the exam. And if you look at this question, which is extracted from 2015 paper 1 exam, well, as it is a non-cal test, so you should expect that the values should be either integers, fractions, and some and in exact form. So okay, first step in part A, which is rather straightforward, is just to ask you to find out the second derivative. And as we know the first derivative, so basically we are just differentiate the first derivative one more time to get that, which literally means the second derivative is just 6x minus 2k. Okay, and then which is easy. And then the point of infractions. So as we know that when the first derivative equals 0, we can determine that that is a stationary point, which means it can be a maximum or a minimum point. But when a function has a point of infraction at somewhere, that means the second derivative at that point is equal to 0. So mathematically, this sentence can be transformed to that. So what does that mean? As we have found the second derivative in part A, which we can directly apply the result from there. So as f double prime 1 equal to 0 from the condition given, so 6, 1 minus 2k equals 0. So k is literally 3, which is exactly what is required in part B. So for part C, find f prime negative 2 well. So as we know that k is equal to 3, so f prime x can be rewritten as 3x squared minus 6x minus 9, and f prime negative 2 is nothing but to substitute negative 2 to the function, and you can work out the solution yourself, which is just 15. Okay. In any case, you can you somehow get stuck in part B, so don't give up part C, as you can use the result of part B in part C to get full credits. So just don't give up. Do whatever you can. Okay. And then find the equation of tangent to the curve in equation of tangent. Whenever you deal with equation of tangent, equation of normal, you need to figure out the slope, which is just f prime x. Okay, so in here we the equation of tangent to the curve f at negative 2, 1. So literally it means that the slope, so in the question is written as ax plus b, which means this is the slope. This is the y-intercept. Okay, so from here we know that the slope a is nothing but f prime negative 2, which is found in part C, which is 15. And then we can rewrite the equation as now equal to 15x plus b. Okay. And as the curve passes through negative 2 and 1, which is the condition given here, so we can always say we can apply this here plus b, and we know that b is just nothing but 31, so we can rewrite the equation as minus 15x minus 31. Okay, so for the last question, so it is told, we are told by the question that f prime negative 1 equals 0, which means, okay, this is maximum or minimum, but then the question requires us to explain why it is a local maximum. So we can apply the second derivative case, which is just if f prime prime x is less than 0 at, so when these two conditions are satisfied, at x equal to p, then p is the maximum point. Okay? So from here, we can just apply the result of the second derivative, which is erased, but anyway. So the second derivative, let's recap here, is just 6x minus x, 6, okay? And then f prime prime negative 1 is nothing but just to substitute negative 1 to the second derivative, which is negative 12 less than 0. So we can claim that f prime negative 1 equals 0 and f prime prime negative 1 less than 0. As both conditions are satisfied, we can say that f has local max at when x equals negative 1. That's the application of second derivative test. And obviously, you can say you can argue that we can say that when x is less than negative 1, the first derivative is positive, and when x is greater than negative 1, then the slope is the first derivative is negative. It's just like you create such table f x and f prime x. This is x less than negative 1. This is x equal to negative 1, and then x greater than negative 1. So this is less than. So it's greater than 0, 0, and less than 0. So the graph should be like that at this point. Okay. Or you can construct a table like that. Then you can also make this argument that the graph of f has a local max when x equal to negative 1. Or you can apply the second derivative test. Either way is acceptable. Okay, so that's the end of the episode, and I hope you enjoyed the video.